In this lesson, we will discuss the difference between systems and control volumes. In all areas of engineering, including fluid mechanics, the conservation laws are vital for analyzing the behavior and performance of devices. For example, these laws help us determine the lift produced by an airfoil, the increase in pressure created by a pump, or the amount of power we can extract from a turbine. There are two approaches to analyzing engineering devices. The first approach is called the control mass or system approach, which will be denoted by the subscript sys. In the system approach, we focus our attention on a set of fluid particles as they travel through the device. The second approach is called the control volume approach, which will be denoted by the subscript CV. In the control volume approach, we focus on the region of space occupied by the device. The control volume is surrounded by a control surface, which is denoted by the subscript CS. To help illustrate the difference between the system and control volume approaches, let's take a look at fluid flowing through a pipe. The section of pipe we wish to analyze is outlined by red dashed lines. At time t1, a specific amount of mass, highlighted in pink, occupies the section of pipe. This mass is called a system. The control surface is marked by the red dashed lines and the control volume is inside the control surface. So initially, both the system and control volume occupy the same region of space. At a future time t2, the control volume and control surface stay in place, but some of the system has flowed out of the control volume. When analyzing a device, it is usually much easier to observe the region of space occupied by the device rather than track the individual particles as they travel through the device. Although many devices are fixed in place and rigid, such as the pipe we just discussed, that is not the case for all devices. Sometimes it is necessary to have a control volume that moves or deforms. For example, a jet engine is filled with air, fuel, and exhaust gases at time t1. The control volume is the region of space occupied by the jet engine and outlined by the red dashed lines. The system is the pink shaded area. At time t1, the control volume and system occupy the same region of space. At a later time t2, the control volume has traveled to the left while the system has been expelled to the right. In this case, the control volume has moved but not deformed. On the bottom of the screen, we have an example where the control volume moves and deforms. A balloon is initially filled with air at time t1. The control volume is outlined by the surface of the balloon and the system is shaded in pink. At this time, both the control volume and system occupy the same region of space. Air is allowed to escape, and at a future time t2, the control volume has moved to the left and become smaller, while some of the system has left the balloon.